Hello students.
Hello teacher.
We are here to carry out titration practical. I hope you still remember what titration is all about.
Yes,
ma'am. Okay. What's titration? Okay.
A titration reaction is defined as a type of reaction between an acid and base to undergo a neutralization reaction using a suitable indicator in order to identify the concentration of the acid and base.
Good. Now we have our acid and we have our base. So we are going to carry out this practical to see how a base will neutralize the acid, of which we have our indicator that will enable us to get the endpoints, which shows that neutralization has taken place. The acid we are going to use is sulphuric acid or tetraoxosulfate acid. Then our base is sodium carbonate. We have our indicator as methyl orange. This enables the endpoints. One will see a color change. These are our wash bottle with our distilled water. These are distilled water, our measuring cylinder, volumetric flask. This is a pipette. We have our funnel. We have our burex. This is called rectal stand with our conical flask. I believe you still remember the work of this.
Yes.
The white eyes. They enable us to see the clear color change. Good. This is what we call weighing balance. We're going to weigh out sodium carbonate. Make sure that your weighing balance is at 0.00 gram. 7 gram. Okay. Take your time to make sure that you get up to 7. Okay. Now we have 7 grams of our sodium carbonate. Now, if you notice one thing about this sodium carbonate, you see that the solution is not clear.
Yes.
Now, what made it not to be clear is because this is a weak base. And you know, weak base dissolve partially. They dissolve partially. So it cannot be clear as a strong base. We're going to make it up using 500 ml volumetric flask. Now at this point, you have to make use of your wash bottle so you can get the exact measurement of this 500 ml. Now our base is ready. Then let's prepare the acid. Remember, this is sulphuric acid.
Yes.
This is a stock bottle. We need to fetch a little quantity of this acid to a reagent bottle. Please note, every solution you prepare, you have to level it, because acid and base in a solution has the same appearance or color. You can see they are all colorless. So for you to identify the acid and base, you must do what? Label it using a paper tip. Then remember our base. Okay. Then we want to pick formula of the tetraoxide with 6. Do you add water to acid or acid to water?
Acid to water.
You add what?
Water to acid.
What's the reason?
It is to avoid any reaction or any splash of the acid by pouring the acid in water.
Good. So now we have our measured acid. We want to make it up to mark in 500 ml volumetric glass. Remember, you have to use your whiteboard tool to make it up to mark. Remember to rinse your glasswares with what? Distilled water. Now the titration program. This is our burette, and what's supposed to be inside the burette?
The acid.
Then the pipette.
The base.
Now we have to put down a label showing that this is what?
An acid.
Acid. Okay. Now add the acid to the burette. Now, at this level, you have to reduce the level of the acid inside the burette to come down to this 0 point by using the knob clip and watch. Remember to remove your funnel before carrying out your practical, because even a drop from the funnel can add a thing to the burette. Let's pick our what? Base. In titration, we have a standard measurement of the base we are going to use to titrate a particular volume of the base, or particular volume of the acid, which is the 25 cm of what? Good. Now, we are going to add our indicator, which is methyl orange. We're going to use 2 drops. Maximum of 2 drops of what? Methyl orange to enable us get the end point of the neutralization. Shake. Now, as the acid is dropping, you watch the color change. You can see there is a color change.
Yes.
So you watch carefully. Of it, the first experiment, we normally call it rough because we are trying to get the exact change or end point of the reaction. So we watch and add some drops of acid. You can see the color change.
Yes.
So what's the reading?
22.8.
Good. So our rough factor is 22.8. Initial reading is 0.0 because
We start from the
we start from the
beginning.
beginning of the burette or from the zero value of the burette. Okay, now let's go for our first title. Fill in our burette again. Of course, we have to check and make sure that it is at the zero value, which is the what? The initial value of the burette. We discard. Then let's get our base. Easy, easy, no. Just take it easy, take it at the time. And don't remove your hand immediately. Good. Then our indicator, 2 drops. You can feel the color change, right?
Yes. Yeah.
Then we titrate. You can pause to view the color change. Pause to view the color change. Okay. Pause. View the color change. View it. As you can see a clear color change now.
Yes.
So let's take our reading.
Adjust the
24.20.
Yeah.
Okay. Then we discard. Refill our burette with our acid. Okay. Then adjust the volume to get down to 0. Watch carefully, okay?
Yes.
Then you discard. Let's get our base. Okay? No, we can. Let's adjust it. Okay. So sorry, okay? But it's good that you're here so that you can learn. Okay? I hope you are getting all we are doing here. If you have questions, you can also ask so that you clarify, okay? Easy, easy, easy. Okay. That's for the second title, right?
Yes.
Remember our indicator with two words? Two drops. Good. You can view the color change.
Yes.
Then let's titrate. Okay. Just view. You can also view it to know whether there is reaction or a change. See, you're getting a change, slight change. Okay, I think we have a visible color change now.
Yes.
Okay, so let's take our reading. You can see there is difference in the value because already the burette is saturated with the acid, so there should be a change. That's why we have to run it up to 3 good times before we finalize to give us a visible endpoint. The value is 18.50. Why the previous one is what?
24.20.
So we are having a very far value. That means our neutralization should be between 18 and 20. So let's go for the third one, the third title, to have a clear endpoint. Gradually, easy, good. Then our indicator, 2 drops. So, I don't know, you may see me doing this. I'm trying to remove some bubbles from the dropper because if there is bubbles, it will give you that exact drop you are looking for. So you have to remove some bubbles then and have a clear view of your drops. 1, 2. Now we have a visible color change now.
Yes.
Okay. So what's the value? 18 point what? 70.
18.80.
Okay.
18.80.
Good. Then, if you notice one thing, our rough title is what?
Higher. 22.80.
Then our first title.
24.90.
Now, that's the essence of running it over and over, at least 3 consecutive times. You can see that our second and our third has a close range of neutralization.
Yes.
Now, this shows that neutralization takes place at 18 points. Now, what would have been a problem why the first title got to 24 is that we didn't observe the color change earlier.
Yeah.
So we overused the acid before we could have checked the color change. So the color change has taken place long ago before we observed it. If you are not observant, probably you are not making use of this clip the way it ought to be, but you have to go by drops. Drop by drop, you drop, you shake, you wash. So if you use the clip and open it like tap to be running down without you observing the color change. So that's one of the reasons why such will take place. Then, if you carefully observe, you see that our second title and our third title has a close range, but we carefully observed the what? The color change, which lies on 18.80 between 18.80 and 18.750. So this is now our value for this reaction.
Excuse me, madam.
Okay.
Please, ma'am. In some of the titration questions I've seen, they usually work with 3 drops of the indicator. So my question here now is, the 2 drops that is added that we use today and the 3 drops that I always see people use, what is the main difference of this change in the drops of the indicator?
Now the 2 drops is a minimum, while maximum is 3 drops. Probably you added 2 and to you is not clear enough to see the color change. So we make it 3. And that's the maximum. You can't add more than 3. Because at that 3rd drop, you should be having a clear view of the color change.
Does it mean that the higher the drops of the indicator, the faster the rate of the reaction?
It's not a faster, mind you, it's an indicator to enable you see a visible color change. That's the essence of it. So, one, you have to have a clear view of the indicator first. So when there is color change from your titration, you also view it clearly. That's the essence of it. So, as you can see, we have gotten our endpoints of raw, first title, second title, third title. Now, we're going to run an average. We have to calculate the average of this to fix volume of the acid used.
Please, madam, is there any substitute to some of these apparatus we use here today in this titration practice?
Good. If you must use any substitute, it must be an accurate measure of what is given to you. Now, you must use your bullets and you must use your bullets. And they are all calibrated. They have their standard measurements. So these 2 must be the same. For the base, you must use a pipette, and for the acid, you must use a pipette. Now, you can now substitute using, like you can see, we use 500 ml of measuring cylinder for the acid and 500 ml of volumetric flask. Now, if you run a measurement of these 2, you see that they are all the same. So when you talk about substitute, these are kind of substitute you can do. But when it comes to titration, you can't substitute for bullets and pippettes. But in your measurements, when preparing your acids and your base, make sure that the measurements you're using for the dilution is the same. If you're using 1000 ml, make sure that it's 1000 ml volumetric flask. If you're using 500, make sure that whatever you're substituting with is 500. That's the essence of this calibration, to tell you that they are of the same measurements. As you can see, it is written 500 ml, and this is also written 500 ml. So they are of the same measurements. So we diluted the acid in 500 ml, and we diluted the base in 500 ml. Any other question?
I have a question. Teacher, please, when we are doing the titration experiments, can you tell us the necessary and possible precautions we need to undergo so as to attain the correct readings?
Good. First of all, your precaution starts with the apparatus, your glasswares you're using. Make sure you rinse them with your what? Distilled water. Then, the burettes, knowing fully well that you're going to make use of the acid on the burettes, you must rinse it with what? The acid being used. The same thing goes with that of your conical flask, which you're going to use for the base. You you rinse it also. After rinsing with your distilled water, you also make sure that there is no drop of water inside the jar. You want to make use of the base inside it. Then another precaution is your white tiles to enable you to see a clear view of the neutralization.
Yes.
Because if you place it here now, there will be some color view.
Yes.
Variations.
Color.
Yes. So with the help of these white tiles, it has a clear view of what the endpoints will be. That's the another precaution. Then know you very well that you are making use of a conch acid.
Yes.
So when handling a conch acid, make sure you are with your protective measures is highly needed. Wear your hand gloves to avoid the acid not to touch your skin on your hand, because you know it's very costly and dangerous. Then your lab coat. Mind you that this material orange, it has a color. In case if you're not wearing a lab coat, something may happen that it will touch on your body, on your clothes, sorry, and it will stain your clothes. So, but if it's stained on your lab coat, you can easily pull off and wash, not on your clothes. Then our weighing balance. Make sure you, ensure that you place filter paper on it. You don't place your base you're going to use on the surface of the weighing balance. Sorry. Now there is knob here that shows off and on, and for you to correct the mode of the weighing balance. Then you use your filter paper, place it on top of it. Make sure you zero, because this filter paper you're looking at has weight. It has its own weight. So when you place it, you tell the weighing balance to make it 0. So it will go back to 0 value. Now weigh the weight of the filter paper, and you can see the filter paper has 0.7, okay, 0.82 grams. Then for you to carry out a particular measurement of your base, you press the tile button. It will return back to 0. Now the weight of the filter paper is off. It's cancelled out. Then it will not give you the actual weight of your quantity of your base. So these are part of your precaution. If not, if you didn't take this precaution, you will add up both the weight of the base and the weight of the filter paper, and which may give you an error wrong measurement.
Excuse me, teacher.
Okay.
Why are we rinsing the breads and putting with the substance which needs to be added into them?
It is already diluted. The acid is diluted to our required measurement, and the base is also diluted to our required measurement. Now, remember we rinse the apparatus with distilled water, and every drops counts. So there is a possibility that some particles of distilled water inside it. When you add up the acid to the purity, it will add up the value or add more dilution to the already diluted acid. So you take that precaution so that you won't have variation in your calculation or in your value you are picking from the elements. Yes. Any other one? Let's add up to get our average title of this acid used.
So we have
20.50. 20.50. So that's our average volume of
acid
use. And remember, it must be in C. Yes. Reason being that these are what we know as volume. They are in liquid form, so they are in volume. It's when it's in solid form, we call it gram. But if it's in liquid state, it is in volume. But you measure, you use some apparatus to measure the quantity. But if it's in a solid state, it's gram. Measure gram in gram. Okay.
Yes.
We always say acid and base in neutralization gives what?
Salt and water.
Can we check whether this is actually giving us salt and water? Yes. Okay. Let's check. So you use here neutralization of acid and base gives salt and water is no longer a news. You have carried out the practical and it's confirmed that it gives what? Salt and water. Good. Here is the end of our practical for the titration. In our next class, we are going to calculate some. Yeah, we have some calculations on this titration. In our next class, we are going to do the calculation. There are some other calculations attached to this practical concerning this acid and base. One, we didn't know the concentration of the acid we used. We didn't also know the concentration of the base we used. We need to calculate the concentration of A, which is the acid, and also the concentration of B, which is the base. Am I communicating?
Yes.
Yeah.